Okay, we're going to talk about critical points, local maximas and local minimas. We talked about that briefly in the last question we were doing. I remember I gave you an example of a function that looked like this on a graph, and it technically went on forever. So when they're talking about local, again, they mean in the neighborhood. So this gives us our maximum, this gives us our minimum. Okay? These are local maximums and minimums. What we're going to be doing in this question is very similar to what we did in our last one. We're going to find out where this is increasing and decreasing, and we're going to talk about critical points, how they affect our graph, and how we can solve them. Okay? So, our very first equation is given by this. In order to find what this graph's slopes are going to be, we're going to derive this. So when I find f or y prime, we're going to get 4x cubed minus 24x squared plus 36x. Okay? So this is our derivative. I can factor out 4x, actually, 4x, and I'm going to get x squared minus 6x plus 9. That is our y prime still. Now remember, because I want to find critical points, I want to set this equal to 0. I want the slope to be 0. So we know we can get a couple critical points here. Now, first off, we're going to set this equal to 0. 0 equals 4x. That's when x is equal to 0. And this bracket here I need to factor. Okay, so I'll factor this on the side. X squared minus 6x plus 9. Well, because the a is a value of 1, I just need two things that multiply to this and add to this. That's going to give us x minus 3 times x minus 3. Which can also be written as one bracket, x minus 3 squared. So I'm going to use that one bracket, and 0 is equal to x minus 3 squared. When I root both sides, I still get 0 is equal to x minus 3. X equals 3. So I have two critical values here. These two critical values are important because we're going to eventually put them into our graph. Okay? Now remember our critical values, and we're going to call these intervals now. We know we have some graph that's going to have critical points or turning points at, oops, that's not 0. One of them will be at 0, and another one will be at 3. Okay? So we have some graph that may do something like this. It may come down, go up, go down. For all we know, it could have critical values that increase and then hit horizontals at those points, or maybe change. We're going to figure it out. But what's very important is these are our critical points, one of them being when x is equal to 0, the other one being when x is equal to 3. So we're going to talk about when x is less than 0. So x is less than 0. We're going to talk about the in-between, when x is greater than 0 but still less than 3. And the final one when x is greater than 3. These critical points we know will be either increasing or decreasing between these points. Okay? Now what's important here is we've technically split this question up. I split it up into a 4x and into a x minus 3 squared. Okay. We did that for the critical values. What I'm going to do is I'm going to actually put them in our graph as those points. We know we had 4x as one of them, and the other one was x minus 3 squared. Now I'm putting these in because what I'm going to try to find out is I'm going to separate them. Okay? And I'm going to find values for both of them. So in other words, when 4x is less than 0, between 0 and 3, and greater than 3, does 4x give me a positive or a negative? And when x minus 3 squared is in these exact same values of x, does it give me a positive or negative? And what we're going to find out is when 4x is multiplied by x minus 3 squared. What do we get? Do we get a positive or negative answer? Who knows? Okay. So our first example is when x is less than 0. So I'm going to say when x is maybe negative 1. Well, 4x is going to give us what? If x is less than 0, a negative times 4 is going to give us a negative answer. Right? And in this case here, if x is less than 1, so a negative number, we're going to get a negative inside the brackets, but it doesn't really matter because whatever's in the bracket is going to be squared. Anytime we square something, what type of answer are we going to get? A positive. Doesn't matter what's underneath here. So in other words, I really don't even need to continue testing that. I know at every single point of this, we will have a positive because we're squaring it. The 4x is what's important. And the first one, we're going to get a negative value. When it's between 0 and 3, in other words, a positive, so when we're between 0 and 3, 4 will give us a positive answer. And again, when x is greater than 3, well, 4 again is going to give us a positive answer. The reason I broke it down this way is so we can see when we multiply them, we're going to be multiplying a negative, that's when I refer to the 4x, times a positive, that's our x minus 3. And that's what these two are here, a negative times a positive. Well, we're going to get a negative answer for our derivative. Same idea here, a positive and a positive, well, that will give us a positive. And then it's the exact same from before. I broke it up that way so we know we have a negative to start, then a positive and a positive. So what that means is our derivative is, because it's negative, decreasing at this point, increasing at this point, and again increasing at this point. So the last thing, oh, did I draw too many of these? 6. Oh, sorry. That's not referring to f, that's referring to f at x. F at x is decreasing here, increasing here, increasing here. What's happening here is f at x is less than 0, greater than 0, and greater than 0. Okay? What that means for our original graph is that we're decreasing, increasing, and increasing. So it means we have some curve. Okay, so the curve is heading downwards, heading upwards, and heading upwards. So when we go to graph a form of this, before 0, we were decreasing, then we increased and increased again. So think of it like this. We were decreasing our original graph, then we started increasing, and then we started increasing again. Okay, those are our critical values. We have some form of the graph like that. We're decreasing before this critical value, then we increase, we hit a horizontal, and then we increase again. Okay, and here's our other horizontal. So those points were all very important, those critical points, because we don't actually know what's going to happen after each time. That's why we have to test each of them out.